me, Jeline Rimasog, BSB1 student, major in Human Resource Management. So today I am going to discuss about patterns and numbers in nature and the world. Pattern defined as regular, repeated, recurring form or design. Pattern in nature are visible regularities of form found in the natural world. These patterns recur in different contexts and can sometimes be modeled mathematically. We see patterns every day, from the layout of floor tiles, designs of skyscrapers, to the way we tie our shoelaces. Natural patterns include symmetries, tree spirals, Mendel's waves, forms, tessellations, cracks, and stripes. Studying patterns helps students in identifying relationships and finding logical connections to form generalizations and make predictions. Let's take a look at this pattern. What do you think will be the next shape in the sequence? It should be easy enough to note that the pattern is made up to two shapes, circles and square. Beginning with the circle, the two shapes that alternate. Logically, the shape that should follow is square. What number comes next? So each term is 2 more than the previous term, so therefore the next term should be 11. Patterns indicate as a sense of structures in organization that it seems only humans are capable of producing. These indicate creative and amazing furnishing. It from this perspective, some people see an intelligent design. The first pattern that we're going to discuss is about symmetry. Symmetry indicates that you can draw an imaginary line across an object and the resulting parts are mirror image of each other. So example, butterfly, Leonardo da Vinci's Vitruvian Man, and the starfish. One of the example in nature is an butterfly. The butterfly is symmetric about the axis indicated by the line. Note that the left and right portions are exactly the same. This type of symmetry is called bilateral symmetry. Next is Leonardo da Vinci's Vitruvian Man. Shows the proportion and symmetry of the human body. So, ito yung kapag tinignan mo ang sarili mo sa harap ng salamin, yung nakikita mo sa left side ay nakikita mo rin sa right side. There are other types of symmetry depending on the number of sides or faces that are symmetrical. Take a look of this image. This starfish has a 5-fold symmetry. Note that if you rotate the starfish, you can still achieve the same appearance as the original position. This is known as the rotational symmetry. The smallest measure of angle that a figure can be rotated while still preserving the original position is called the angle of rotation. A more common way of describing rotational symmetry is by order of rotation. Order of rotation. A figure has a rotational symmetry of order n times n-fold rotational symmetry if 1 over n of a complete turn leaves the figure unchanged. To compute the angle of rotation, we can use the formula 360 degree over n. Example is the snowflake. The pattern on the snowflake repeats 6 times, indicating that there is a 6-fold symmetry. So using the formula, the angle of rotation is 60 degree. Although many combinations and complex shapes of snowflakes may occur, which leads some people to think that no two are alike. If you look closely, however, may snowflakes are made perfectly symmetry due to the effect of humidity and temperature on the ice crystal as it forms. Why best use hexagon in making honeycomb and not any other polygons? To conclude why hexagonal formation are more optimal in making use of the available space, meron tayong tinatawag na packing problem. So, what is packing problem? It involves finding the optimum method of filling up a given space such as a cubic or spherical container. So, dito, meron tayong dalawang gagawin para i-compare para ma-prove that the hexagonal formation are more optimal in making use of the available space. Proof. Suppose you have a circle of radius 1 cm, each of which will then have an area of the pi square centimeter. We are then going to fill a plane with these circles using square packing and hexagonal packing. So, unahin natin dyan yung square packing. So, ito yung una natin gagawin. I-compute natin yung percentage ng square packing and hexagonal packing. To compute the percentage ng square area covered by a circle, so mula sa figure na to, so ito yung gagamitin natin na formula. So, mula sa figure na to, meron sa bawat square, meron lang isang circle. So, pag pinagsama natin ang portion na to at saka na portion na to, ay makabuo tayo ng isang circle. Kaya yung area ng circle is pi squared centimeter over 4 squared centimeter. And then, sa bawat square, meron tayong 4 na square centimeter. So, i-divide lang natin times 100%, and that is equivalent of 78.54%. So, ito yung percentage ng square packaging. So, next natin is hexagonal packing. So, for hexagonal packing, we can think of each hexagon as composed of 6 equilateral triangles with side equal to 2 cm. So now, to compute the percentage, kunin muna natin yung bawat area ng triangle. The area of each triangle is given by A is equal to side squared times square root of 3 over 4 cm. So, again, meron tayong 2 cm. So, i-substitute lang natin 2 cm squared times square root of 3, and the centimeter of squared is 4 cm. So, makakancel natin to. So, therefore, the area of each triangle in the hexagonal packing is square root of 3 cm squared. To compute the percentage ng hexagonal packing, gagamitin natin formula. The area of the hexagon is 6 square root of 3 cm squared. Bakit? Dahil sa bawat triangle, merong square root of 3 squared centimeter. So, times 6 lang natin, kaya naging 6 square root of 3 centimeter squared. So, yung area ng hexagon natin is 6 square root of 3 cm squared. Dahil meron tayong 3 circle ang kasya sa loob ng hexagon, it gives a total of 3 pi cm squared. So, ito yung isang circle. Pag pinagsama natin yan, makabuo tayo ng dalawa pang circle. So, using the formula, so, substitute lang natin times 100%. So, the percentage of the hexagonal packing is 90.69%. Now, comparing the two percentage, we can clearly see that using hexagon will cover a larger area than when using squares. Therefore, we can conclude that hexagonal formation are more optimal in making use of the available space. Thank you for watching this video. Hope you learned something.